This is a demonstration of the Forest Manufacturing Model 480i horizontal blade traveling table bandsaw. I have other videos going through all the features of the 480i, so I'll skip that part, just go through the basic outlines of this machine and what we're test cutting today. So the 480i, horizontal blade, obviously, cutting in a horizontal plane, not coming down like a guillotine, it's cutting horizontally. Head height on this one is a hand crank, manual up and down. It has an electronic digital readout to show the head height, be programmed in millimeters, inches, or furlongs, whatever you go for. Traveling table, it's a steel traveling table. Powered, variable speed, speed range, standard 0 to 2 inch per second. You do have the ability to overspeed that though. You can run it probably as much as twice that fast, but please ask me before you try to make any changes to do that to one of my machines. It's in the control panel, you just want to make sure what you're doing there. This machine uses our variable speed control panel, so the blade drive motor, big gold thing over there, is a 5 horsepower 3-phase brake motor, inverter duty. We have it set up to run with a brake, which requires a little magic. Basically what we do is we have the brake disengage anytime the motor's running at any speed and then re-engage. So you have nice positive blade stop. When you hit the stop button, the blade stops now instead of spooling down. It's controlled with an inverter. The table drive is also controlled with an inverter. We have automatic end of travel stop, so going forward or reverse, it hits the end of travel and stops. If it's going forward, it hits the end of travel stop, and the blade is running, it'll also stop the table drive. Right now I'm running my blade speed at 3,000 feet per minute. The blade I'm using is a 1 inch wide, 3 tooth per inch. I've got about 60 PSI on the pressure regulator, which gives me about 16,000 PSI of blade tension. That's on the low side. So we could run this blade as high as about 25,000 PSI if we thought we needed to. We don't. This is not my first test cut, so I've done some experimentation. But if you want to try run it harder, faster, get more out of it, you can run your blade tension higher. I tell my customers use all the blade tension you need, maybe a little bit more, but using excess blade tension unnecessarily will lead to bearing wear, premature bearing wear, and other things. Basically, don't run your car 120 miles an hour. You don't have to. This machine has door cabinet switches, such if you open one of the cabinet doors, you can't run the blade drive motor. It also has a blade breakage detector. The blade breaks or is not present, you can't run the blade drive motor. Low air pressure switch. And a lockout so you just can't run the blade if it's detensioned. So I'm going to make this test cut here. This is a customer provided workpiece. This customer is actually the owner of this saw. They are working with these plastic totes, and as part of their production process for a specific carrying tote, they want to cut about right here. This is a 2-part piece. It's got some black plastic feet that snap in, and basically just want to cut the top off. We've done some preliminary test cutting, so I've got a good idea what my speeds and feeds are. The way I'm going to do this cut, since I'm being a little cautious, I'm going to start off the blade speed at 3,000 feet per minute. Again, it's possible to overspeed that, but ask me before you do. You can do it just by changing some settings, but we'll want to make sure that's the right thing to do. So blade speed currently 3,000 feet per minute. I'm going to start the table drive off at 0. So the way I'm going to cut this for demonstration purposes, I'm going to start the blade drive motor, let it reach full speed, takes about 3-4 seconds. Then I'm going to set the table advanced speed to 0. I'll start the table advanced, then I'll slowly increase the table advanced speed. I'm running it at about 20% of full speed. Full speed is 2 inches per second, so I guess that's 0.4 inches per second on the cut speed. And then we have a separate potentiometer for return speed. I just leave that 100% because that's dead spotting your process. This machine comes with a remote control pendant. So I've got saw start and stop, table forward, reverse, table stop, all on here. The table advanced speed is controlled here on this potentiometer. The table return speed, which, like I say, you pretty much always leave at full speed, is on the panel face. So, start the blade drive motor. Dust collection. Then I'll start the table drive and slowly ramp up that speed. So the table is mounted slightly off perpendicular, such that when you put a rectangular workpiece on the table, we start by cutting a corner first. I have preset the blade height here. I like to let it catch that corner, get into the blade, get the blade into the workpiece before I start ramping up the speed. Okay, we've got a bite now. Noisy. Drawing about 5 amps, so we're not actually working the motor all that hard right now. We do have room to go faster. Go. I'll let it run to the end of the table. When the table hits end of table stop, it'll stop the table automatically, it'll stop the blade automatically. I'll bring the cut workpiece around. For my customer, this is actually the trash bit, recycle bit, and it's fuzzy but nice and flat. I'm gonna go get the actual piece. And here we go. So the objective, as I understand it, is to cut just above these little snap ends. That's where I measure, that's where I set it. You see that? Oh, that's nice. It's just barely above those little snap ends. Nice, nice, nice. So, that's what the machine does. It will cut these things just fine. Like I said, on test cuts like this, because I have a limited number of work pieces, to test on. My objective is always to make a quality cut first and a fast cut second, because nobody cares how fast I can cut something if I can't do a good job of it. So we were operating, in this case I was running about 8 hertz. So round about 0.4, maybe 0.35 inches per second. Definitely room to increase that. The blade drive motor was not the limiting factor. I'm pretty sure we can run the table faster. Might run the blade a little faster, so could certainly get more speed out of the table feed. If I had more pieces to play with, I would keep iterating up. I suspect the customer winds up with something close to 50 to 100% faster cut speed on these products, but I'm gonna call it a success. One other thing I'm gonna note here, this machine right now is running on a generator. This machine is being exported overseas. It's running on 50 hertz, 3-phase, 400 volt power. So we're having to run off a generator. And so in addition to just proving the machine works, we're also stress testing it on the actual power it'll be run on. We send machines all over the world. I've worked with all sorts of odd voltages, and this is how we handle it, by hiring a generator to test run it on the actual power it'll be run on by the customer. If you have any questions, please feel free to call us or email us at Forest Manufacturing. Thank you for watching.